Hi class, this is Neil, and this is lesson 10, the second day of review for us. We will have a test next week that will be open note, open book, meaning you can use the resources on Google Classroom to help you complete the exam. But the purpose of today's lesson is really to review for the exam. So again, this is the first of two videos. In the first video, we'll just be looking at the do now. All right, so let's go ahead and read the problem. Lutetium, I think that's how you say it. So maybe it's lutetium, I'm not really sure. 177 dotatate is used to treat tumors, such as ones that are related to the hormones affecting the activity of nerves, and is effective where other treatments fail. Lutetium-177 has a half-life of 6.07 days. If a patient is given 78 milligrams, determine to the nearest day the amount of time needed for there to be approximately 8 milligrams of the drug in the patient's body. So why don't I just underline the given, and that's going to help us a little bit later on. So if you don't remember where a problem like this came from, it actually comes from Unit 8, Lesson 6. That's where we first took a look at half-lives. Anytime we're dealing with a half-life problem, we're going to rely really on our most basic equation that deals with exponential decay. And that's A equals P times 1 minus R raised to the T. Anytime we're dealing with a half-life problem, our rate is 0.5 for a half. Now, in this problem, we need to think about what is the amount of medicine the patient started with. And it's 78 milligrams. We're interested to find out what is the time to the nearest day. And one thing we really need to be careful of with half-life problems is that when we set up our equation, T really represents the number of half-lives. And we'll need to come back to that later in the problem. So we're interested in what is the time it took for the patient to end up with 8 milligrams. So our A value here is 8. Okay, so I'm going to use this information to rewrite my equation. I'll have 8 equals 78 times 1 minus 0.5 raised to the power of T. I'm just going to simplify that equation a little bit further, and I would have 8 equals 78 times 0.5 raised to the power of T. Okay, so I'm going to want to isolate the exponential part of the equation. So to do that, I'll first need to divide both sides by 78. Cancels this out. And now I really would need a calculator to figure out what is 8 divided by 78. I wouldn't want to do that by hand. I should get 0.10256. And that's equal to 0.5 T. Anytime I'm solving an exponential equation for its variable, and the variable is in the exponent, I need to use log to do that. So I'm going to take the log of 0.5 of both sides of the equation. So on the right side, what that does is let me isolate my variable, or isolate my T. And then I've got on my left side log of 0.5 of that decimal there, 0.10256. Now, thinking back to a previous lesson, to input this in our calculator, we need to really do log of the argument, so log of 0.10256, and divide that by the log of 0.5 equals t. You won't be able to do this without a calculator, so let's go into Desmos and see what this gives us. So I actually need to type out log, and then I'll put parentheses 0.10256, close the parentheses. Now we're dividing that. I'll type log again, log of parentheses 0.5, and I get 3.28545. I'm just going to take that 3.285 as my answer. But here's where I have to be careful. So t equals 3.285. Remember, t represents the number of half-lives. So this is 3.285 half-lives. We need to find out to the nearest day how long did that take. And we know one half-life is the same as 6.07 days. So I'm going to take that 3.285, multiply it by 6.07, and I'll end up with 19.94, or approximately 20 days to the nearest day. And so 20 days there is my answer. All right, you can pause the video if you need, write that down. And now let's move on to question 2. Okay, so this is really an interpretation problem, a problem where we're going to have to think about what's happening in the equation and what is described for us. So a certain pain reliever is taken in 220 milligram dosages and has a half-life of 12 hours. The function A equals 220 times 1/2 raised to the t over 12 can be used to model this situation, where A is the amount of pain reliever in milligrams remaining in the body after t hours. So I guess one thing to note is that our variable in this half-life problem is hours. It's not the number of half-lives. And where do we think this 12 comes from? Well, it comes from how long one half-life is. So let's read the statements. Every hour, the amount of pain reliever remaining is cut in half. Well, how long is a half-life? A half-life is 12 hours. So this is false, because we're told a half-life is 12 hours. So it takes 12 hours for the amount of medicine in the body, or the amount of pain reliever, to be cut in half. Let's look at option 2. In 12 hours, there is no pain reliever remaining in the body. Well, the way a half-life works is once we go through one half-life, the amount is cut in half. So this would have to be false. After 12 hours, which is one half-life, we would have 55, not 55, my apologies, half of what we started with. So half of 220, or 110 milligrams. Now, if you didn't trust the reasoning, we actually are given an equation here. A equals 220 times 1/2 raised to the t over 12. We can just substitute in 12 into our equation, see what we get. So A equals 220 times 1/2. Replace t with 12. Now if I simplify that, I would get 220 times 1/2. 12 over 12 is just 1. So that actually gives me 110 milligrams. So again, false. All right, option 3. In 24 hours, there is no pain reliever. In 24 hours, there is no pain reliever left in the body. Well, how many half-lives will we have gone through in 24 hours? 2. You're right if you said 2. So that really means that after 24 hours, we would be left with 55 milligrams. So that's half of what we were left with after 12. Every 12 hours, the amount gets cut in half. Now, if you don't trust the reasoning, we can use the equation. Replacing 24 for t. Simplifying that, I get 1/2 raised to the second power. I can input that in my calculator, and I will get 55 milligrams. Option 3 is false. Okay, that leaves us with option 4. In 12 hours, 110 milligrams of pain reliever is remaining. That is correct. And we proved it here. We also reasoned it out here. So that concludes the first video for today's lesson. In the next video, we'll take a look at the examples.